Now I want to talk about something that's called properties of real numbers. Now I'll remind you what real numbers are. Real numbers are all of the integers that we talked about. So numbers like -3, -2, -1, 0, 1, 2, 3, and so on both sides. This is also going to include numbers like 1/2, and 1/2 can be represented as 0.5, so that's included. But it's also going to represent numbers, or it's including numbers like √2, √3, so irrational numbers. All of these are included in real numbers. And so all of these properties will include all of these numbers. So all of these numbers act that way. And the first property I want to go over is called the commutative property of addition. And this is a property of real numbers that they have. Now, generally, the way we write this is the number a plus the number b is equal to the number b plus a. Okay, so if that makes any sense to you, then it's probably an obvious statement. So it's just as deep as saying that 2 plus 3 is the same thing as 3 plus 2. That's something that we already know, that both sides are equivalent, but the fact that this is true is going to lead to many different consequences, and so we need to state that they're true. Now, what does this word commutative even mean? Addition obviously is referring to the operation of adding, but what does this commutative mean? It means to move. If you have a long commute to work or a long commute to school, well, then you're moving a lot, right? So commutative means to move, something that moves. Well, what's moving? A, B, B, A. 2, 3, 3, 2. So the numbers are moving, and that's the commutative part of it. So what are they moving? They're moving through addition. So this is movement through addition, and we know that this is obviously true. We've learned this in other classes, but we're going to put a name to it. We're going to call it commutative property of addition. Now, the multiplication also has this property, and we can write this as a times b is the same thing as b times a. Okay, well, sure, that makes sense. So 2 times 3 is the same thing as 3 times 2. All right, well, that's not too deep. We know that that is true, and we're saying that you can move through multiplication. 2, 3, 3, 2. So these moved through multiplication, and that's what we're trying to say here. So hopefully that makes some sense to you. So we're talking about the movement of multiplication. A lot of this will probably seem silly to you because, of course, numbers act this way, right? Well, as you go higher in math, as it turns out, this isn't always true. In fact, when you go in 3 dimensions, you can't naturally just switch things around and they'll be in the same order. In fact, you can, if you have ever played with a Rubik's Cube, you can find that rotations are not always the same if you rotate in a 3D space. Anyway, I'm off on a tangent already. Let's go. So associative of addition. Okay, what is this talking about? So I can write this as a plus b plus c is equivalent to a plus b plus c. Okay. Now, let's check that this is not commutative. A, B, C, A, B, C. Okay, so the numbers didn't move. What changed? The parentheses changed. The groups changed. Okay? So what does associative mean? Well, it means to associate, like to group things. Let's put this in numbers and kind of see what we're talking about. So I'll call it 2 plus 3 plus 5 is the same thing as 2 plus 3 plus 5. So if we just write this as just some numbers here, this is what's going on. Notice 2, 3, 5, 2, 3, 5. So the numbers aren't moving. What's moving? I can group things differently. So I can group these numbers together, or I can group these numbers together, and I'll still get the same solution. Okay, this is going to be very important to us coming up in the class, and you may have studied about, or used this property in other classes before. Most likely, if you've studied any math at all, you've used this property, but we're actually putting a name to it. Again, this is happening through addition, so this is grouping through addition, okay? Associative of addition. Associative multiplication, it's basically the same exact property except it's multiplication. So AB times C is the same thing as A times B times C, okay? Again, ABC, ABC, so the numbers aren't moving, but the parentheses are moving. And again, I can turn this into multiplication, and we can see that it is, again, exactly the same equivalent statement, okay? So we're switching groups through multiplication, but it's still totally equivalent, okay? And that's what this associative means. It means to group, and we're grouping through multiplication, okay? The next one is called inverse of addition, okay? So what is inverse of addition? Well, inverse of addition is like A plus its opposite equals 0. Okay, and I like to pick on the number 2 a lot, so I'm going to continue to pick on number 2. And that's like saying 2 plus negative 2 equals 0. This is also saying that every real number would have an opposite, okay? And if you put them together, that this equals 0, okay? It seems pretty obvious that 2 minus 2 equals 0, and we're going to call this the inverse. And I actually think of it as the opposite rule. This is the opposites of addition. So it's the opposite of adding is subtracting, okay? So that's what the inverse of addition property of real numbers is. So there's going to be an inverse of multiplication too, okay? So the inverse of multiplication is going to look something like A 1 over A equals 1, okay? And again, I can pick on 2, so 2 times 1 over 2 equals 1, or half of 2 equals 1. And this is kind of like saying the opposite of multiplication is division, okay? That's, I think, a little more clear here because, I don't know, it depends on how you think about it. This kind of looks like 2 times 1/2 still, right? But we're focusing on the 2 and the 2 here. So these are the inverse. And sometimes you will catch me saying that this is the inverse of 2. And sometimes we need what's called the reciprocal, which is flipping a whole number upside down like this. And sometimes I actually refer to it as inverse. Okay, so that is the inverse, or I think of it kind of as the opposite of multiplication is division. All right. So the next thing is called the identity of addition. Okay, let's look at it. So any real number plus the number 0 equals that original number. And again, I can pick on the number 2 for A, and we see that that's true. Alright, well, what is this on about? What is this identity stuff? Well, the identity is referring to, well, what is identity? Identity is like the id, it's like the self, and so this is trying to say that something is maintaining its identity. It's staying true to itself. And so something is not being changed because it's staying true to itself. What's staying true to itself is the number A. So A plus 0, any real number A, plus 0 is still itself. And so 2, or the square root of 2, still equals itself. Any number, any real number, plus 0 equals itself, okay? Stays true to itself. Identity of addition. Identity of multiplication. Okay, so what number x would this be A? What number makes it true? What number times any real number makes it true to itself? Well, that is 1. So any real number times 1 is itself, and this is the identity of multiplication. So 2 times 1 equals 2. Root 2 times 1 equals root 2. Okay? It's staying true to itself through multiplication. the distributive property. Now, the distributive property is different than the other properties we talked about because it's not the distributive property of addition, and it's not the distributive property of multiplication, because it's both, okay? So A times B plus C, this group here, can be distributed as A times B and A times C. And you may have seen this in other classes where you're distributing something, okay? So the most confusing thing is that this is not a distributive property of addition, it's not a distributive property of multiplication, but it's both. It's both addition and multiplication. So that's the first one we've dealt with so far that has that feature, okay? And so if I pick on those prime numbers again, 2, 3, 5, well, then I'm saying that 2 times 3 plus 2 times 5 is the exact same statement, okay? So hopefully that is making some sense to you. I'm distributing that too, okay? Well, if you've taken previous algebra courses, then you know that going this way is called factoring, okay? And since these are equivalent statements, you can go either way, and so this is going to be called factoring, okay? And we're going to get to that very soon. Properties of 0. 0 is an extremely abnormal number. It's the only number. We have infinite numbers, and it's the only number that acts this way. Any number times 0 is 0. This is like the opposite of the identity rule. It is actually making any number turn into itself. Okay, that's like the opposite. So any number like root 2 times 0 is 0. Any number times 0 becomes 0. Okay, it's kind of like a simulation, if you've ever seen Star Trek The Next Generation. Anyway, so this is a property of 0. Oh, I can draw that better. So that's a property of 0, and only 0 acts that way. And another property of 0 is this. Any number, any real number divided by 0 is what we're going to call undefined. We don't have a definition of what it means to divide by 0. Okay? If you allow this in your mathematics to be able to divide by 0, all kinds of logic errors are going to start happening. So this has to be built in any kind of logical system that you can't divide by 0. And something that I always tell students is that probably seems so abstract and all that, but the universe also knows about it. And if you ever, watch a YouTube video or something about black holes, this is a crude drawing of them. It's just a funnel, but as it gets closer and closer to its center, you have this kind of like the radius is 1 over the radius, and the radius is going to 0. And we don't understand what that means, okay? Because all of our math, all of our logic just seems to completely break down when you start thinking about this. And also, if you're interested in things like black holes or something, which, my crude drawings is pretty much going to be the same drawing except tipped over. So this is some of the drawings of black holes if you look in astronomy books. Again, if you go backwards in time, if you go back to that time equals 0, we have no idea what this means, okay? Because all of our logic system, it just totally breaks down. You start getting numbers like 2 equals 5 and things like that. We'll see some of this. Of course, we're not going to talk about the physics. That's just for fun, but it's going to break it down, and we will see some of that throughout the semester. Much simpler examples, but we will see some of that where the logic is starting to break down. Okay, algebra does have its limits, after all. So I hope this video helps. Please let me know if there's anything I left out that you think I should have put in, and also just let me know if you have any questions. Okay, bye.